Thank you very much for this stimulating, fascinating talk and for making all these connections from conceptual modeling to all these other areas, and for using these examples of COVID that makes not only for a very important application of conceptual modeling, but a very timely one. I will ask, we have already many interesting questions, so I'll ask very brief questions so that I have the chance to ask many of the questions from the audience. You know, I'm obsessed with history, so my questions are always start this way. I think it's important for the area to know its own history. So you are a physicist, and I know that in your PhD in the end of the 80s, the beginning of the 90s, you were already doing innovative conceptual modeling work with the O method, and then later with OASIS and so on. But the question is, how did you come from physics to conceptual modeling? What was the path there? What triggered your interest, Oscar?
Well, this is a nice question. I would say, Giancarlo, that I have always been a conceptual modeler. When I was younger, I was just making a joke with my friends when we were going out for drink beers, saying that when people were asking me, what are you doing? I was asking, just joking, okay, I am an intellectual, because I like thinking. But it was a joke. But I'm saying that because when I studied, I decided to study physics, it was because I wanted to understand reality. So to me, physics, as philosophy also, I like philosophy. I have always liked philosophy very much. But physics was fascinating to me because it was a way to understand how the nature is doing things as it does. So when I entered computer science, I think that in some way this goal of understanding the reality was the same to me. So in some way, what I'm doing now is, again, studying physics, but from another perspective, from the perspective of this conceptualization problem. And I think that I need to be good in thinking. While I'm not so good doing, for instance, the worst topic in the school to me was the manual activities. So it seems that, well, I like this joke that I was saying of being an intellectual had some kind of semantics that I was not aware of it before.
Great, Oscar. So my second question about history, and also that is related to even to your thesis, right? I know you were a big fan of the Frisco framework, this framework that back then in the 80s and in the beginning of the 90s was trying to establish foundations for information systems engineering. And this was a very interesting piece of work that many people who are joining, so students, we have many students in the audience, so people who are joining the community now are not aware of, right? Many interesting people involved, so Falkenberg, for example, Colette Roland, Ronald Stamper, the creator of organizational semiotics. I think at a certain point, Yair Wand and Terry Halping, even James Odell was involved. So can you say something about Frisco, the influence of Frisco in your work? And if you don't think we need a Frisco 2.0, so coming back to this kind of work in establishing the foundations of conceptual modeling and information systems engineering.
Thanks a lot for this question, Giancarlo. I think that is extremely relevant. I love Frisco. I think that when I was starting my PhD, I needed, following this attempt to ontologically understand the concept that I was using in my research work, I needed some kind of framework of reference to understand what was a system, an organizational system, an event, an object, an attribute. I know that you know very well that, because to me, it was a discovery of the ontologies. To me, Frisco, I was completely out of the field, and I understood that without having a framework of reference, a conceptual framework of reference, you have nothing, because I realized that I was talking with other colleagues, even with my supervisor, and I realized that we were talking about different things, because we were using, for instance, the term event, and I was meaning one thing, and he was meaning or she was meaning a different thing. So Frisco to me was an extremely well-written and well-built document. I have never understood why there is no Frisco 2.0. I think that this was an amazing work. To me, I am a strong defender of Frisco. I moved from Frisco. I mean, the ontology that I use in my PhD was the Bunge's ontology. It really was the time of the Bunge, the Weber Wand Bunge ontology. This is why I admire a lot Bunge and Jair Wand and Weber also. I have not had the chance to meet in the past him, but I had the chance to meet. I am working now with Roman that is working with works of Bunge, and I am very happy to be friend now of Jair, one that when I was student to me was like the god of the ontologists. And the only thing that I will tell you is I will be extremely happy to participate in any way in any attempt to create such a Frisco 2.0.
I agree. That would be very, very relevant. And just connecting to this, we're going to have Jair in our EROSS series of seminars in few weeks. We're just confirmed.
I won't miss it for sure.
Exactly. So they did very, very pioneering work. Ron Weber, Jair Wand, based on Mario Bunge's work. Bunge unfortunately passed away very recently. He was 100-something years old. He was still working into the end of his life. So very, very relevant work.
Let me share with the audience that I think that the continuation of this work has been mainly the UFO and the OntoUML and all the work that the NEMO group that you lead has done, is still doing. Because in some way, to me, this VWW ontology that we use was a very simple version or something that needed more details. That is what I see that you are doing year after year.
Yeah, thanks for mentioning that, Oscar. I will move to the questions of the audience. There are many interesting questions. So the first one, how can we include moral and human values in the models you were talking about?
Well, this is a very good question, and it's a typical question. I think I don't know how to do it, but I'm convinced that it can be done. It's just a matter to try to understand what are the functional materializations of these moral issues. And when we do that, I mean, we can create immediately, we can project in, let's say a robot, we can create a robot that is responding according to the moral concepts that we identify and represent in our model. So there is no way, in my opinion, and I know that this is controversial, but there is no need or no need to say no. Moral concepts it's not possible to identify them and to put them in a model. I think that they can be, again, it's going to be a problem of conceptualization. It's not easy to conceptualize moral, but I think that it is a very nice exercise, because if we try to do it, we will understand better some situations where things, even when we talk about human problems, are not so clear. So I think that we are, this is like the discussion, this makes me make the connection of the discussion of the soul. These concepts that we have, it appears that we have things as humans that are not physical. Well, from this perspective that is very strong, everything is physical. And I am perfectly aware of the controversy of these points, but when we look at people, I don't see any scientific reason to say that given a particular way of behaving cannot be modeled at all. So we can create, and for sure we could create models, robots that have different moral behaviors. And it happens with people. Because I think that if people are behaving in the way they behave, there is always because their programs are reacting according to some rules that are still to be discovered. But I don't believe that this is magic, that is something that is just ethereal or just completely unhandleable.
Mm-hmm. So playing the devil's advocate, I'm reading the question, the process you describe can also be realized using non-symbolic approach, such as neural nets. Why would a conceptual modeling-based approach be better? Because for many tasks, for example, natural language processing, the results that these other non-symbolic approaches are getting seem to be better than the symbolic approach.
Wow, this is a very good question. It's a very good question. I'm just right now studying that. I am reading a book that is about deep learning, and I am studying neuron networks, and I am fascinated by this metaphor of the neurons. I'm wondering, because at the end the concept is there, but it seems that the brain execution model is representing concepts through a connection of neurons. So I wonder where is what is clear to me is that the representation level that neurons are providing is just very special. But at the end there is a concept, and I think this is what I would answer to this question. It is true that the non-symbolic representations are there, and they are making us to identify reality and to talk and to create languages, but the concept is always there. If I was now using the metaphor of, okay, if we have some neural network and there is no concept behind, at some point somebody will have to tell the machine this is a car, or we are looking for images, or we are looking for cats or faces, or whatever we are looking for. So my answer would be that it's something to be explored, but even if we talk about non-symbolic approaches, at the end or at the beginning, the conceptual connection must appear in some way. So we should explore what is the right way to use conceptual modeling in this context. I would like to write something as a paper about conceptual modeling of neuron networks, for instance, to identify if there is something as a conceptual neuron, or this kind of concept that I think that could be the case that will exist, will appear in the next future.
By the way, thank you, Oscar. By the way, on August 12th, we're going to have here in our series of talks, Melanie Mitchell. She wrote a very, very interesting book called Artificial Intelligence, a Guide for the Thinking Human, and which discusses these issues, the limitations of the numerical processing for AI and the importance of paying attention to common sense and things like that. So
let me say something, because I like this question very much. I was thinking in something similar, that if we take the conventional software image, the comparison, if we look at the software that we create and we look at the electrical circuits that would be the equivalent to neurons, if somebody wants to understand what is the semantics of programs, could be confused if he takes or she takes the electrical connection, because in that case it's just the materialization. So we are using electronic circuits as we are using probably non-symbolic neuron networks, but this is just the instrument that this execution model is used in order to materialize the concepts. So I think that there is a mix of levels there, of conceptual levels, that is very important, and it's not easy, but it's very important to separate clearly and to manage concepts on the one side and the representations, either symbolic or not symbolic, on the other side, but not mixing them.
Mm-hmm. Oscar, would it be useful to relate the data of an individual with their ancestors, with the data of their ancestors, to predict, for example, pathology, or all the information you need is what it's coded on the individual's own genome?
Yes, again, there are very good questions. I think that I had some similar question in the past, and I was referring to the invention of the object notion in software engineering. Remember that it was a very intelligent invention, because we have the object, and the object has its code, but the code is just activated, but through messages. That is the environment. So it could be the case that you have the code. I was thinking that you are a violent person, but if no violent message is never activated, people could believe that you are a peaceful person because you have not had the chance to activate the behavior. So of course our code it is very clearly expressed in metagenomics and in other terms that the expert in genomics are using. But it's clear that we have something that is there. But there is also a response, continuous response to the environment, and this is also creating part and explaining why we behave in the way as we behave. I think that this is just a whole. I mean, we have something that is coming from our ancestors. And I always see, I think that this, if anybody of us makes the exercise of thinking, trying to identify what we are doing was done by either my father or my mother, we always find, I think that it's not, if we make the reflection, we see ourselves projected in our ancestors. This is a natural way. But it's also true that we have an evolution that is just in some way justified by the execution model that we have. The code, the human code, we say run program, and the program is run. In our case, we have the DNA. The DNA is transcribed into RNAs. And if something, the DNA can be correct, but if there is something from the environment interfering in the process of generating the RNA, there is a problem. And the problem is not in the source code. The problem is in the environment. So this is true, but this is part of the problem. This is part of the execution model seen in a holistic way, seen as a whole. So we have to understand well the program that we are. We must understand both the written rules and all the interferences that may appear due to the context where we are reacting.
Mm-hmm. Oscar, the next question is a question that 14 people join in asking. So I guess this is something that people experience in their practice. So this is related to the challenge of the posed by the interdisciplinary nature of conceptual modeling, because you're doing conceptual modeling with domain experts who are not even computer scientists, right? So communicating the role and the relevance of conceptual modeling to that domain, how do you approach this challenge, and do you see possible paths to bridge the communication gap between modeling experts and domain experts in the future?
Yes, again, a great question. I would say two things. The first thing is the work that we are doing together with Steve, Veda, Lois, trying to characterize conceptual modeling research, because I have clearly detected, I have clearly felt that, as you say, when you approach other communities that, in my opinion, are doing conceptual modeling, they are not aware of that at all, because they have never heard the term conceptual modeling. I can give some examples. For instance, artificial intelligence. Many people that are working in artificial AI with knowledge representation, knowledge models, well, they are conceptual models, and they don't use the term. They would never say that they are working in conceptual modeling. What is a real shame, because we are losing a lot of strength doing the same without realizing that we are doing the same. When I was talking, for instance, with Sylvie about explainable artificial intelligence, conceptual modeling appears to be something that is coming from the external outsider, when this is not the case at all. So I think that the problem is a human problem. I think that, as I said before, it is related to the idea of going from the sapiens to the genius. I think that the sapiens, we as sapiens, we conceptualize for free, as I said. So we are not aware of that. So we are not able to, when we fight and we think that the other, by definition, is stupid. I mean, if you don't agree, you are wrong. This is the normal sapiens behavior. I think that conceptual modeling should mean that, okay, if you don't agree, I know that there is something, you are not stupid, so you have a different mental model. So the genius perspective, that sounds a little bit like something for children, but it's to understand your model. I mean, I should make the effort of understanding why you are thinking what you are thinking. And if you do the same, in these cases, finding an agreement is very easy, because I understand that you want that, you understand, and I want something different, and so we just adapt our mental models to find an agreement. This is what makes people genius. And I think that, unfortunately, for instance, most of our politicians in the history are sapiens. And this means that if this land is mine and you don't agree, either I kill you or you kill me. So the war is the only way to solve the problem. This is the typical, just exaggerating, this is the typical sapiens pattern. And the question that you were asking is a little bit, I think that we are not aware of that, and it's very easy to think that the other is the guilty, the other is the one that is the responsible of my problems, and well, I think that I think that this from sapiens to genius is a serious issue, because we need to create this club of genius, or at least people that want to change their conceptualizing capability in order to make it explicit. I mean, we should be aware of going a little bit out of ourselves and to even understand our models from an external perspective, because in that way you see that people are doing things because it's normal. I mean, the brain has some general rules, and you can understand why others are doing what they are doing. And from that, as I told you, everything can be solved in a much more effective way.
Thank you, Oscar. There is this whole, and I agree, by the way, that one of the key roles of conceptual modeling is meaning negotiation. So that there is this whole community of people doing knowledge representation in bioinformatics. So people like Robert Stevens and Carol Goebel and so on, that, you know, people have been building networks of ontologies in bioinformatics. I don't know if you're aware of this. So one question here is, how does your work differ from this proposal in this community of ontology-based knowledge representation for bioinformatics?
I would, yes, this is relevant work, and I would consider this relevant, related work. But I think that from what I see in this context, the conceptual perspective, the distinction between the conceptual level and the instruction and the physical level is not as clear as it should be. I think that we need to have a more in-depth conceptual discussion to determine, ontologically speaking, what are the main concepts and what are the precise relationships. And I think that there are some approaches that are working in that direction, but using this dichotomy between problem space and solution space, even if some people are closer to the problem space, they are still too much closer to the solution space. I mean, the real data are just determining what kind of final decisions you take. And at the end, there is a problem. There is the problem of the genome data chaos, because there are many data representations that are just incompatible, are just inconsistent, and this is generating a lot of problems when you want to infer information that is going to use, for instance, for diagnosis, where we cannot accept any mistake. So all these works are, to me, really, really relevant. And I would like, for instance, to have more details about conceptual models of what kind of constructs are behind these knowledge models, and well, even a kind of foundational ontology to be able to compare different knowledge models. That I think that is the main problem, that sometimes is difficult, even when we have such knowledge models, and if they have different representations, it's not easy to compare them and to understand what is wrong, what is good, what should be represented in a different way, and so on.
Mm-hmm. Again, a question here that many people joined to ask this question, Oscar. You've used your experience in modeling software and other computational artifacts for the challenge of modeling life. What about the other way around? Are there any lessons learned from your life engineering project that can influence how we do conceptual modeling computer science? Do you expect to find lessons in this way that you can move from modeling the genome that could help us on how we design computational artifacts?
Yes, I like very much the question, Giancarlo. Yes, I don't know. I don't know what to answer exactly. And this is what, as I think that I said before, this is why I am now so interested in studying in depth the fundamentals of neuron networks and deep learning. Because, well, it is, yes, I think that our approach is always based on the idea of conceptualizing in order to convert the model into the code. But when we look at the representation, the non-symbolic representation that neurons systems are accomplishing in what we mean by life, it's very interesting to see that the concepts are just you see, neuron networks must be trained. But also humans, we need to be trained. When we are babies, we don't have all the concepts. We need education. So there is a training process also. So I think that this question is very interesting because probably if we would understand better the brain secrets, and if we would understand, we would be able to understand better how the concepts are inferred from this kind of neuron connections. This would create a way of moving into a different kind of machines, DNA-based machines. Why not? I have read something, not very precise, but I think that it makes sense to have this in mind, because could be the case that from our execution model we have, or we learn, or we detect, we identify capabilities that would be very beneficial for the machines that we want to create.
Models are good when they allow to properly solve problems. That is, they function well in some application scenarios. We thus need methods for such models. We have to focus to build an appropriate analogy and to worry about dependability of models. What is the right focus? Which scope? How to avoid too high complexity of models? How to be sure that the decisions on focus did not lead us in the wrong corner?
Yeah, this is a great question. Sorry to say the same every time. I will have all the questions now because I want to study them.
And I'm glad that you say that.
Again, I don't have the answer, but I can share with the person that made this question my reflection for years. I have been teaching for years conceptual modeling, and I am fascinated by the fact that if I have 20 students, for instance, there are always, and they are master students, there are 2, 3, or 4 of them that are extremely good in doing the conceptual modeling exercise, while there are 4, 5, 6, 7 that for them is very, very, very hard. And I don't know why. I don't know. What I know is that this conceptual modeling capability should be trained, and it's not trained. I mean, conceptual modeling should be a topic that is as basic, at least, as programming. So people should be able to acquire the capability of abstracting well and modeling well, and being able to determine what is essential and what is complementary and this is not the case. But I have the feeling, answering this question, when I talk to normal people, even my friends, I think that we have all friends that talk a lot, and at the end, when they talk to us, we don't know what they are saying because they are very, very inconcrete. They are people that talk a lot, and they are not precise in the transmission of the message. And I don't know why. There are some cultural issues, for instance. There are, I don't know. I have always believed, for instance, that the German language is very precise. So German people should be more precise transmitting messages than Spanish people, for instance, because the Spanish language is very literal, very nice. You can play with the language. You can say the same thing in many different ways. You can have very long, I remember a book from Mario Vargas, Gabriel Garcia Marquez, that it was almost one paragraph, the whole book. This is impossible in German. So my conclusion is that it's impossible to have in Spain a rationalist philosopher, because the language is not helping to that. While it's very normal that Kant is German, because philosophers from this perspective have a very good tool with the language. Said that, I think that it's not clear to me how to evaluate the capability of people to do conceptual modeling, but it's clear to me at the same time that this can be trained, and conceptual modeling should be much more present in the curricula of at least software engineering, if not much other disciplines.
Mm-hmm. I'll ask a final question then, Oscar. So there is one question here about the role of events. So if you are using events foundational theories to map metabolic pathways, I'll make a more general comment on that. I think events have been kind of neglected to a certain extent in traditional classical conceptual modeling, right? So when we do conceptual models, events are simply not frequently there. Although they are an absolutely fundamental aspect of reality. So can you say something about this, about the modeling of events, and in particular, in a domain like this, events should appear very often?
Yes, again, I will use the Frisco and the VWVW ontology as an example of how I solved this problem. Because from the beginning in Frisco, when we were looking at the world as a society of interactive objects, Bunge was also assuming that well, we have objects, and the objects have a structural part, that is the static part, that is just represented through attributes, and they have also a dynamic counterpart. The dynamic counterpart is the event, and Bunge was defining an event as an abstraction of a change of state. And to me, this was very important because I cannot have only attributes. I have attributes in a class, and I must know which attributes are changing, because behind the change of any attribute, there is an event. And so you need to specify behavior in a natural way. So to me, structure and behavior have always been, again, the two sides of the same coin. So you need to specify both. And you have to provide a very clear definition of what do you mean by an event. So an event, in my case, was an abstraction of a change of state of one object. And this was an atomic property of behavior. We can create transactions where we put a lot of events together. This was our contribution to the Bunge's proposal. And in this way, with this notion of transaction, we were able to deal with complexity, because we have the basic units of behavior, our events, that can be combined in order to create more complex units of behavior. And let me complement this with our third dimension that is normally, I don't know if there's any question, but it's always absent. That is the interaction. Because when we look at a software product, we have structure, we have behavior, but we have interaction. That is very important, the way the human-computer interaction. And when we are programming, creating the interface is probably the most complex part, the most time requesting time of the development process. So in our method, from the very beginning, as we wanted to have programs that were just ready to be deployed, we had in the model structure, behavior, and interaction clearly specified. This is part of the ontological background that we were established for our models.
Oscar, there are many people here also thanking you for this great talk. So I join them, and I also thank you very much on behalf of all organizers. It's very generous of you to offer this talk and to stay here answering all these questions. So thank you very much.
Thanks to you.